Hello. Alright. Now am I audible properly? Okay. So myself Keyur Talati. Good morning everyone. I am working as a senior security analyst and here to present a small talk about how we hacked an web application that was integrated with Metamask wallet. Alright. So without wasting time, let us start the session. And thank you all of one who is joining here. Thank you for a valuable time. Okay, so here a small introduction about myself. Working as a security analyst at Fire Compass, that is an Bangalore-based organization. Apart from that, I am working as a cybersecurity club lead at Charosset University, and also a founder of a RDX bot where we are trying to automate the crypto trading. Right, we are developed our own bots that run 100% automatically on the crypto networks. We are using Binance as our platform. You can also connect with me on LinkedIn. I will share the QR code at the end of the presentation. Okay. So first of all, let me tell you a small idea about the web application that we target. So consider it as a kind of a ticket booking system. Like you can take example of a book my show, where we can book the movie tickets and pay in terms of INR, right? So this is an application where you can book the concert tickets and you can have an option to pay with the help of Metamask integrated wallets, and you can make payment in terms of crypto. Alright. So this is the blockchain based web application. So the first vulnerability that we identified was a race condition. Right. I'm telling you one small story about the cancel ticket function. So as we know that once a user book a ticket, then he has an option to cancel the ticket and ask for the refund. So this is the function that we found on the web application. Now I am telling you an idea about the race condition. What is race condition? Suppose there is a user who has a bank account in XYZ bank and he has a balance of 500 rupees. So once he go with any ATM, he can withdraw that 5,000 rupees, right, with the help of ATM card. So the ATM card, the backend will check whether the user has the sufficient balance in that account or not. So once it confirms from the backend that yes, user has the 5,000 worth of credit, then they can withdraw the rupees. And after the withdrawal, the balance will be reduced by the 5,000 and that will be zero. This is the normal scenario. Now just imagine what happened if we send two simultaneous requests to withdraw 5,000. So here the rest condition comes into the picture, where it is a kind of condition where you are able to withdraw more money than you have actually in your bank. So before the backend reduce your money from 5,000 to zero, you are making two simultaneously requests. You are making two API calls to withdraw your money. And as the balance of your bank account is 5,000, your both requests will be successful and you are able to withdraw 10,000 as a result. So this condition is known as the rest condition in software development. This was found in that web application during the pen testing. So the cancel ticket function, as it was implemented with the MetaMask, the developer has developed in a way that whenever a user asks for refund with the help of cancel ticket function, the backend will first unlock the admin's wallet and they will unlock the admin's MetaMask wallet. Then they will initiate the transaction from admin's MetaMask wallet to the user MetaMask wallet, and after that immediately they will lock the admin's MetaMask wallet. So this is a standard flow that should happen. Now let us come for the vulnerability. So here, as you can see, this is the code of the cancel ticket function. When in the first line, if the ticket is valid, if you have booked and cancel ticket, and if backend found that yes, the ticket is valid, then they will unlock the admin wallet. They will initiate a transaction from admin's MetaMask to user MetaMask with the help of a kind of, you can say that suppose I am booking zero point 0.1 Ethereum of ticket, and if I want to ask for refund, it will unlock the admin wallet. It will transfer zero point 0.1 Ethereum from admin MetaMask to my MetaMask, and after that, the admin wallet will be locked immediately. So this is a kind of a source code where you can see that at the end of the code there is a function called lock, lock admin wallet, and with the help of that function, admin's MetaMask wallet will be locked immediately. Now the make payment function, it sends the token on if and only the user's wallet is unlocked. The sender wallet must be unlocked before initiate any transaction. So this is the source code. Alright. So what we have done? So we have sent a large amount of refund request from admin MetaMask wallet. And apart from that, as on a simultaneously basis, we send large amount of web requests to send X amount of Ethereum from admin wallet to attacker's wallet. But as the admin wallet was locked, we were not able to withdraw any amount of Ethereum as we don't have any validity. So on one side, we are continuously sending large number of web requests to transfer the Ethereum from admin MetaMask to attackers of MetaMask. But as the wallet was locked, we were not able to successful. But at that time, if we are logged in as a user and we try to ask for a refund, so as we seen in the previous slide, the admin wallet will be unlocked for let us say 0.5 second, and in that 0.5 second time frame, as we are sending the continuous request, one of the requests from attacker will be executed, and this is the race condition where we are able to withdraw X amount of Ethereum from admin MetaMask to attacker. So this is the race condition that we identified, and not a single withdrawal was happening as it was taking around 0.5 seconds. So 2 to 3 requests at a single attack, we are able to withdraw multiple Ethereum. So I'm going to see a kind of POC. We have confirmed the transition over the Ethereum chain as well. I think the image is little bit blur, but as you can see that we are able to withdraw 0.2 Ethereum with the help of this attack. So this is the story one, where we hacked the admin wallet with the help of race condition. Now coming back to the story two, where we have identified one more flow in the same application. So here the thing is that after reporting this kind of bug, the developer has implemented a kind of a protection where before initiating the payment, they are checking in the transaction as like what is the source of the sender. So as a sender, I want to book 2 tickets. Suppose the price of the ticket is 0.1 Ethereum, then I have to make a 0.2 Ethereum of payment to admin, and with the help of that transaction hash, the admin will generate 2 tickets for me in their web application. This is the standard flow. Now let me tell you one interesting story. While accessing the web application, we identified that the backend was lacking for the proper check for this kind of function. So what we have done, we have initiated a self transaction, and we found that the backend is only checking for the sender's address, and they are checking for the value of the money, value of the Ethereum that they have sent, but they are not checking for the receiver's address. So we manipulate the process. We make a we can say self transaction of 0.4 Ethereum, and with the help of 0.4 Ethereum transaction ID, we pass that ID into the book ticket function. With the help of bird speed, we have intercepted the request. We modify the transaction as, and we found that we are able to book the tickets with the help of a self transaction. So that should not be the case. And yes, we are able to successfully book. I'm showing you one POC. Yes. Is it visible properly? Okay. So in the left side, as you can see, once the user sends 0.2 Ethereum, the verified function check whether the transaction is success or not. If it is not, function will be failed, and if it will check for the sender's address as well as the sender's amount. And once they confirm the same, the 2 ticket will be booked for a user. Right. This is just normal scenario. And the right side we have shown an kind of graph for a attacker scenario where an attacker make a transaction of 0.4 Ethereum into their own account. We can say it is a kind of a self transaction, and we pass that hash into the blockchain application, and we pass that hash, and with the help of a lack of proper configuration, we were able to successfully book 4 tickets for an attacker. And again, there is a function in the web application where you can apply for the refund. So So after booking for the 4 tickets with the help of refund, we were able to drain the Ethereum from admin Metamask wallet. And this was one of the biggest hack that we found during the assessment of a web application. So anyone of you have any queries related to this presentation or anything else? Okay. So here we are complete with the presentation. Thank you for your valuable time. And you can also connect with me on LinkedIn, Twitter, or Telegram if you want. Thank you so much, guys. Thank you.
So, does anyone have any more questions?
Yes. Right. Right. So as an attacker, we are sending large amount of requests. You can assume 10 requests per second. So there is a tool called burp intruder. With the help of that, we can send large amount of web requests to the API calls. And as all the APIs will reject, why? Because the admin's wallet is locked. But it is a kind of frequency of seconds where a valid user is trying to ask for refund. The admin wallet will be unlocked for microseconds. And, and at that time, at that frequency of seconds, one of our API will be executed as a successful. And with the help of that, we are able to drain the Ethereum. Thank you.
So, anyone else? Okay, so that was all from Keyur's side. Can we have a round of applause for Keyur, please?
Thank you. Thank you so much for the valuable time. Thank you.